3.2.3, identify mathematical properties. That is the additive inverse, multiplicative inverse, additive identity, etc. Identify the following mathematical properties below based on the given examples. So the first one that we're going to look at is a times 1 equals a. So this is definitely going to be an example and not a property. So it's going to be in one of these three. Okay, so this is going to help us out. Is this the multiplicative inverse, multiplicative identity, or the commutative property? Okay, so we know that multiplication is happening here, so it's most likely one of these two, right? A times 1 equals a. Now there's not like an inverse or reverse sort of thing happening, and it's probably an identity. And when you think of your identity, you think this is you, this is who you are. So there's almost a repetition. Like if you saw another person with your identity, it'd be the same as you, right? So if you see a multiplicative identity, it's multiplying to still have you, still have who you are. So a times 1 still gives you a. What it is times 1 gives you a, gives what it is. So that's going to be a times 1 equals a. Boom. Cool. Next, we're going to look at x times y times z equals y times z times x. So this is going to be, once again, one of those examples. So is this the multiplicative inverse or is the commutative property? Okay, so good question. And to think about the inverse, remember that it's like the reverse, right? That there's something inverted, different, okay? You expect like a partner between one and the other. Whereas a commutative property, you can think of almost as a commute, like a community works together, doesn't matter the order, right? There's not really a judgment in a community, right? A good community. So the order doesn't matter and it's still the same. And that's the idea here, is that x times y times z is the same thing as y times z times x. Order doesn't matter and it's equal. So x times y times z equals y times z times x. By process of elimination, that allows us to select this one for the last example. And this is multiplicative inverse, right? K times 1 over k, or the inverse of k, the reverse, the 1 over k, okay, equals 1. So k times 1 over k equals 1. That's like 5 times 1/5 equals 1. That makes sense. So those are checked off. Now we have to think about these additive inverses and additive identities, distributive property, associative property. So m, let's look at this first example. M plus negative m equals 0. Well, this is not multiplicative inverse, but it's definitely adding, right? And it's not adding to get to itself, right? That would be identity. It's additive inverse. So because inverse m and then minus m, those are inverses, right? Add inverse. B plus 0 equals b. Okay, so additive inverse. B plus 0 equals b. Well, it's b plus something gives us still b. So that identity stays the same. So we're adding and there's an identity there. So add identity. So you can remember the additive identity is you're adding 0. And the multiplicative identity is you're multiplying by 1. Okay, so those are good. Now we're down to our last two, the distributive property or the associative property. So both of them seem to have parentheses, but this one at the bottom distributes the a to both the c and the d. So this is the distributive property, leaving us with this as the associative property, just rearranging of parentheses.